Welcome back to DemoHub Pod, where we explore the cutting edge of tech and AI, powered by AI.
That's right.
Today, we're going to be taking a deep dive into the world of transformers.
Yeah.
That really powerful architecture that's behind a lot of the cool AI stuff that you're seeing these days.
It's revolutionary.
Exactly. We're going to unpack how they work, why they're so powerful, and what they mean for the future.
You're right.
Think of this deep dive as your shortcut to really understanding what makes transformers tick.
Absolutely.
You shared some great resources with us.
I did.
Including a YouTube video by Andrej Karpathy.
Oh, yeah?
Titled, Let's Build GPT from Scratch in Code, spelled out.
Great video.
Yeah, we've also got excerpts from the Transformer model on machinelearningmastery.com.
Okay.
Transformer, deep learning architecture, on Wikipedia, a Medium article titled Transformer Architecture Explained by Amanatullah. A YouTube video titled Transformers Explain the Architecture Behind LLMs on the channel AI Coffee Break with Letitia. A page on Geeks for Geeks titled Transformers in Machine Learning.
Okay.
And an AWS page titled What are Transformers in Artificial Intelligence?
Those are excellent sources.
Yeah. So let's jump right in.
Okay.
First things first.
Yeah.
How do transformers process information
Okay.
differently than those traditional neural networks like RNNs?
Well, RNNs process data sequentially, one thing at a time,
Right.
but transformers, they analyze the entire sequence of data all at once.
Oh, wow.
This parallel processing is what makes them so incredibly efficient.
So instead of reading a sentence word by word,
Yeah.
the transformer looks at all the words simultaneously.
Precisely. And they rely on these things called tokens, which are essentially numerical representations of the text.
So each word gets its own unique code, and the transformer uses those codes to understand the entire sentence.
Exactly.
Okay.
These tokens are then transformed into word embeddings, which are vectors capturing the semantic meaning of a word.
Yeah.
It's not just identifying the word, but understanding its meaning in the context of the sentence.
Got it.
Yeah.
That kind of reminds me of how in the Karpathy video,
Yeah.
he breaks down training data into like these chunks of characters, and then shows how the model like predicts the next character based on different context lengths.
That's right.
It's learning those relationships, not just memorizing sequences.
Right. And to make things even faster,
Yeah.
transformers process multiple independent chunks of data at the same time in batches.
Okay.
This helps maximize the efficiency of those powerful GPUs that we use.
Okay, that makes sense.
Yeah.
But if the transformer's looking at all the words at once,
Yeah.
how does it know the order of the words in the sentence?
That's where positional encoding comes in.
Okay.
It's a technique that gives each token a sense of order within the sequence.
Okay.
So even though it's processing everything in parallel,
Yeah.
it still knows which word comes first, second, and so on. So it maintains the structure of the sentence even while analyzing it as a whole.
Exactly.
That's pretty neat.
Yeah.
But what really sets transformers apart is this concept of self-attention, right?
Yes.
I'm really curious to understand how that works.
Self-attention is the heart of the transformer architecture.
Okay.
It allows each token to analyze its relationship with every other token in the sequence.
Hold on. So each word is checking out every other word in the sentence to figure out the context.
That's a good way to put it.
How does that even work? Each word is essentially asking,
Yeah.
how much attention should I pay to each of the other words to really understand my role in this sentence?
Okay.
And to figure this out, they use something called queries, keys, and values.
Queries, keys, and values.
Yeah.
That sounds a bit abstract.
Well, think of it like this.
Oh.
Imagine you have a question. That's your query.
Okay.
You search for information that matches your question. Those are the keys.
Okay.
And then you extract relevant info from those matches. Those are the values.
Okay.
So in a sentence, each word generates a query, looking for matching keys, in other words, and extracts valuable information from those connections.
Wow, that's a really cool way to think about it.
Yeah.
So each word is like actively engaging with the other words
Yeah.
to figure out its place in the overall meaning.
It's a beautiful dance.
That's cool. And to capture different types of relationships,
Yeah,
transformers use multi-head attention, right?
that's right.
So it's running multiple attention mechanisms in parallel.
Yep.
Like having different groups of words focusing on different aspects of the sentence's meaning.
Exactly.
Karpathy uses a great analogy
Oh, yeah.
in his video talking about how vowels might be looking for consonants or vice versa.
Right.
It really helps illustrate how different attention heads focus on different kinds of relationships within the data.
It's a powerful way to extract a nuanced understanding of the relationships between words.
Now, all this analysis sounds computationally intensive.
Uh-huh.
How do transformers manage to do this efficiently?
They use a technique called scaled dot product attention.
Okay.
It normalizes the relationships between words and prevents extreme values, which helps make the calculations more manageable.
So it's like a balancing act to make sure
Yeah.
the attention scores stay within a reasonable range.
Precisely. This scaling is especially important at the beginning of the training process when the model is just starting to learn.
Okay, that makes sense.
Yeah.
So I've got these powerful self-attention mechanisms at play.
Yes.
But what happens next? How does the transformer actually generate output?
Okay.
Like if you ask it a question, how does it come up with an answer?
Well, that's where the classic encoder-decoder structure comes in.
Okay.
Both the transformer model from machinelearningmastery.com and the Wikipedia page on transformer deep learning architecture
Right.
both explain this well.
Right. The encoder-decoder.
Yes.
So the encoder takes the input sequence,
Yeah.
it's like a question,
Right.
and creates like a rich representation of its meaning.
Yeah.
And then the decoder uses that representation to generate the output sequence, like an answer.
Yeah, think of the encoder like a master chef,
Okay.
taking raw ingredients, the words,
Yeah.
and creating a delicious dish.
Okay.
A complex representation of the sentence's meaning.
Yeah.
And then the decoder
Yeah.
is like a skilled server who takes that dish and presents it to the diner
Okay.
in a way that everyone can enjoy, by generating a coherent output sequence.
I love that analogy.
Yeah.
It really helps to visualize the process.
Good.
But I'm curious about how the decoder actually uses the encoder's output to generate the output sequence.
Mm-hmm.
Does it just directly translate the encoder's representation?
It's more nuanced than that.
Okay.
The decoder generates the output sequence step by step,
Okay.
word by word.
Yeah.
And it has a masked attention mechanism to prevent it from peaking at future words.
Oh, interesting.
This ensures that the predictions are based on past context only.
So it's like the decoder is reading the sentence linearly, word by word,
Mm.
focusing on what it's already generated and the encoder's output to predict the next word.
Precisely.
That's really cool.
It is.
So we've covered how transformers use self-attention to process data
Yeah.
and the decoder's structure to generate output.
Mm-hmm.
But it seems like they could do so much more than just predict the next word in a sentence.
They can.
What are some other applications where transformers are making a big impact?
Transformers are super versatile.
Okay.
They're used in machine translation,
Okay.
sentiment analysis,
Yeah.
question answering,
Yeah.
a whole bunch more.
It's like they've opened up a whole new level of language understanding and manipulation.
Yeah,
It's incredible.
it is.
So how do they go beyond just predicting the next word?
Well, one key ingredient is cross-attention.
Okay.
This is where a decoder pulls information from a separate encoded source.
Okay.
For example, in translation, the decoder might look at an encoded French sentence
Yeah.
to help it generate an English translation.
So it's like having two separate transformers working together.
Exactly.
One encoding the source language
Yeah.
and the other decoding it into the target language.
You got it.
Karpathy talks about this in his video too, right?
She does.
When he talks about encoder-decoder models for tasks like translation
Yes.
and how they contrast with decoder-only models, which are more for like text imitation,
Right.
it's fascinating how adaptable they are.
It is.
We've gone from understanding how transformers process information
Yeah.
to seeing how they can be used for all these different tasks.
Hmm.
Now, I'm really curious about these large language models,
LLM.
LLMs everyone's talking about, yeah.
Yeah.
How do they fit into this picture?
Well, LLMs are essentially transformers that have been trained on massive data sets.
Okay.
This gives them an incredible grasp of language and knowledge.
Mm-hmm.
They can capture complex linguistic patterns,
Okay.
generate human-like text,
Yeah.
and even perform tasks that previously seemed impossible for machines.
It's amazing how these LLMs like GPT and BERT have become so popular.
Yeah,
It all stems from this transformer architecture.
right back to the transformer.
Yeah. Karpathy does a really good job of explaining the scale of these models.
Yeah.
He compares the size and training data of his smaller Shakespeare-generating transformer to something like GPT-3, which is just mind-bogglingly huge.
It's huge.
It's incredible to think about the amount of data they're trained on.
It is.
But how do they actually learn from all of this information?
One key technique is masked language modeling.
Okay.
The model is trained to fill in missing words in a sentence,
Okay.
forcing it to learn the structure and nuances of language.
It's like a giant game of fill in the blanks that helps the model understand how words relate to each other.
Exactly. A great example is in the YouTube video, Transformers explained the architecture behind LLMs.
Yeah.
It gives a good example of BERT's training objective, showing how it's trained to predict those masked words.
That's really helpful. Now, I've also heard about fine-tuning when it comes to LLMs.
Right.
What exactly is that?
Fine-tuning is a way to specialize a pre-trained LLM for a specific task.
So you don't have to train a model from scratch.
Nope.
You take a pre-trained LLM and fine-tune it using task-specific data.
Precisely.
Okay.
The Medium article on transformer architecture describes this as post-training, teaching a transformer specific tasks after it's already been trained on a massive amount of data.
That makes a lot of sense.
Yeah.
So we've gone from the basic building blocks of transformers to this incredible world of LLMs and how they're trained. It's been quite a journey. But it feels like we've just scratched the surface.
Oh, yeah.
There's so much more to explore.
Sure.
Like the potential applications of transformers beyond language processing.
Absolutely.
But before we dive into that, we'll take a quick break.
Okay.
Stay tuned. We'll be right back to continue our deep dive into the world of transformers.
That's good.
Welcome back to DemoHub Pod.
We're jumping right back into our deep dive into transformers.
That really mind-blowing architecture that's like changing the game in AI.
Absolutely.
Yeah, we've covered a lot of ground already.
Yeah, we have.
From tokenization and word embeddings to that amazing self-attention and those massive LLMs.
Huge.
We saw how they're training on these like mountains of data.
It's crazy.
Yeah, and how we can fine-tune them for like specific tasks.
Exactly.
It's like giving a general purpose AI, a specialized skill set. Super powerful stuff.
But there are some limitations too.
Oh, yeah, for example.
Things we need to be mindful of as we explore this tech more.
Yeah, that's a good point. I mean, like every powerful tool has its, quirks and things to watch out for.
Right.
So what are some of the challenges that come to mind?
Well, one thing is the sheer computational cost of training these massive models.
Right. Yeah, we touched on this with LLMs.
Yeah.
But it's worth really emphasizing. I mean, training a model with billions of parameters.
Billions.
Yeah, requires ridiculous computational power.
It's a huge barrier.
Especially for researchers or smaller companies.
Right.
Without, those big budgets.
Exactly. And as these models get even larger and more complex, the cost just keeps going up.
Right.
And this raises a question of accessibility, because if only a few companies can afford to train these models, it could really stifle innovation.
That's a good point. It's like having a powerful engine, but only a select few have the keys to the car.
Exactly.
So how do we make sure that this technology is democratized and available to a wider range of people?
It's a big question.
Yeah.
And thankfully, there's a lot of work being done to address it.
Okay, good.
Researchers are exploring new techniques for more efficient training.
Okay.
And there are initiatives to make computational resources more widely available.
Yeah, that's really encouraging to hear. I mean, we need to make sure that this tech benefits everyone.
Absolutely.
Not just the select few.
Everyone.
And speaking of benefits, one of the things that's always kind of stupid me about transformers is their potential for interpretability.
Right.
Because it's like we're trusting these models to make important decisions.
Right.
But we don't always understand how they're reaching those conclusions.
That's a key area of focus in transformer research.
Okay.
It's often tough to trace the decision-making process.
Yeah.
Especially in these complex models.
Yeah, they're like black boxes.
Yeah, unlike simpler models where you can often see the logic step by step. Transformers can be a bit more opaque.
Right. So even if a model is performing really well, it can be hard to know why it's making certain predictions.
Exactly.
And that can be a little unsettling.
Yeah.
Especially in areas like healthcare or finance.
Right, high-stakes areas.
Yeah, where those decisions have real-world consequences.
Absolutely, and that's why researchers are working on making these models more transparent.
Okay.
We need to understand the why behind the predictions, not just blindly trust the output.
It's like having a brilliant advisor.
Yeah.
You want to know their reasoning behind their recommendations, not just blindly follow their advice.
Right.
So what are some of the ways researchers are trying to improve interpretability in these transformers?
Well, one approach is developing visualization tools
Got
that
it.
help us understand how attention is working within the model.
Okay, so we can see which words or features the model is focusing on.
Exactly. It's like getting a glimpse inside the model's brain
Yeah,
to see what's capturing its attention.
that's really cool.
Another approach is using techniques from explainable AI,
Okay.
or XAI.
XAI.
Yeah, this involves developing methods that can provide human understandable explanations
Oh, okay.
for the model's predictions.
So it's like having the model explain its thought process
Right,
in a way that we can actually understand.
exactly.
That would be amazing.
It would be a game changer for building trust
Yeah, for sure.
and confidence in these systems.
Absolutely. And is that like an active area of research?
Oh yeah, it's an area of active research.
Okay, cool.
We're still in the early stages,
Yeah,
but there's a lot of progress being made.
that's awesome. I mean, as we continue to unlock the potential of transformers,
Yeah,
it's so essential that we do so responsibly.
we have to.
We need to ensure that these models are transparent, accountable, and used for the benefit of humanity.
I couldn't agree more. It's a collective effort.
Yeah.
Researchers, developers, policymakers,
Everyone.
society as a whole needs to work together to guide this tech in the right direction.
Absolutely. It's a powerful tool
Very powerful.
with incredible potential.
Oh yeah,
But like any tool, it needs to be used wisely and ethically.
for good, not for evil.
Exactly. So as we move forward with transformers, let's keep these considerations in mind.
Agreed. It's about striking a balance between innovation and responsibility.
Yeah.
We can harness the power of this tech while ensuring that it benefits humanity in a positive way.
I think that's a great point to end on for now. But we're not done yet. We've still got a lot to unpack about these transformers, including some of their amazing potential applications beyond language. So stay tuned for the final part of our deep dive. Welcome back to DemoHub Pod. We're wrapping up our deep dive into transformers.
It's been quite the journey.
It really has.
Yeah.
We've gone from understanding how they process information
Yeah.
and generate output
Right.
to like some of their crazy applications.
Yeah.
And we even talked about responsible development and interpretability.
It's important.
It is.
So now let's shift gears a bit and look towards the future.
Okay.
Because transformers are already making waves in fields way beyond natural language processing.
Yeah, that's what I'm really excited about. I keep hearing about these vision transformers.
Oh, yeah.
And how they're applying the power of self-attention to images and videos.
It's pretty amazing how adaptable this architecture is.
Yeah, it was initially designed for language,
Right.
but it's proving to be incredibly versatile.
Absolutely. It
Yeah.
really shows the power of self-attention.
Yeah.
As a fundamental way to analyze and understand complex data.
Yeah, no matter what kind of data it is.
Exactly, whether it's text, images, or even something completely different.
And we're already seeing some really cool applications.
are.
In areas like medical imaging.
Yep.
And autonomous driving.
It's exciting stuff.
It's amazing. Imagine transformers helping doctors diagnose diseases earlier,
Yeah.
or enabling self-driving cars to, navigate more safely.
The possibilities are endless.
It's mind-blowing. As these models keep evolving,
Yeah,
they're going to play an even bigger role in our lives.
absolutely.
It's exciting and a little bit scary at the same time.
Right. It's important to remember that with great power comes great responsibility.
Yeah, we need to make sure these advancements benefit everyone and that we're creating systems that are fair and unbiased.
And accountable.
Accountable, exactly.
It's a shared responsibility.
For sure.
Researchers, developers, policymakers,
Everyone.
we all need to work together to make sure this tech is used for good.
Well said. As we wrap up this deep dive into transformers,
Yeah.
I'm left feeling a sense of awe at the power and potential of this technology.
It's truly a game changer.
It really is, and I can't wait to see what the future holds.
Me neither.
A huge thanks to all of our listeners for joining us today.
Yeah, thanks for listening.
We hope you found this deep dive informative and thought-provoking.
If you want to learn more,
Yeah.
there are tons of resources available online.
Yeah, for sure.
Research papers, open source code, you name it.
It's a rapidly evolving field, so stay curious.
Absolutely.
And don't forget to like, share, and subscribe to DemoHub Pod for more deep dives into the world of tech and AI. We'd love to hear your thoughts on transformers. What applications are you excited about? Leave a comment below and let's continue the conversation. Until next time, keep exploring and innovating.